Please, everybody, welcome Logan Smith.
Is that how this works? Come on. Cool.
All right, thank you, Logan.
Hi there. So we got that introduction. Bevel, we're a technology studio for AEC. So we're applying the spatial technology into the AEC industry. I come from an architecture background. I was actually a licensed architect here in Portland before starting this company. And so today I want to talk about where the technology is right now for architecture, for construction, what's available, what's easy to use and can be applied right now, what people are starting to do, and then how this is shifting and moving the industry forward and where we're going eventually. So, starting out, present. First thing, as an example, I recently designed a building for LinkedIn Learning. We teach classes with them so that we could use it as a teaching content so that people can teach classes about Revit. And in designing this, I got to bring back my architecture roots and use all of this spatial technology in the design process, which was really fun. Starting out, we had to pick a site. And so I started out trying to look at maps and then needing to understand this space. I knew that I needed someplace that was a corridor lot, that was in the right sort of density part of the city. And so I went to Google Earth VR and I could just tromp through and explore the city and find an unoccupied corridor lot that met all of my requirements. So I got to pick out my site like a giant with the full understanding of the context of the space. And then without needing to even go to a site visit, although with real architectural design, I always do a site visit, within just a few minutes, I could find my site and I could start actually working on the design. Then the next steps, I went to Google Blocks and I knew the basic program that I needed to achieve. And so having learned about the site conditions, I could start massing out my programming. And so I've got cafe there, I've got office, I leave a lobby in the middle, and I had all these design constraints that I could start working with in 3 dimensions. This sort of design process makes a huge difference, I believe, architects are creating spaces. We're constantly working in drawings, but the point is to make places for people to occupy, and it makes a big difference to have people thinking in 3 dimensions as they're designing 3-dimensional spaces, and that's what this is all about. Once I had the basic diagram laid out, I could export that directly into Tilt Brush and start working out the detailing of the space. Start laying out window patterns, start figuring out how we're getting into spaces, diagramming with arrows and words, and by the time I was done with that process, I was a few hours into this, and already I had a really good idea of how the space should be, and I've been able to just grab it and expand it and occupy the space throughout the entire process of this very early design. Then I could actually take what I'd made in Tilt Brush, import it into Revit, and start hardlining the design, where I use that as a backdrop, and it's actually a 3-dimensional overlay. So when I look in plan, I've got all of my notes there, and I start laying out my walls and my windows and rationalizing it and getting it precise. Because this, what we're talking about here, this is using very much consumer-focused design tools. In fact, Tilt Brush is not intended to be a design tool. It's a very good art tool for people who want to make spatial art. It's some fantastic stuff made. But it doesn't have the precision that something like a BIM program has. So you bring that in and you can overlay and right from the start, the design is built with 3 3D in mind. All of those pieces are really fun, and I'm actually excited to see what Wild brings to the table with having a more collaborative kind of process that's more focused on designers. And then you get to the point where you're doing the more typical architect's job of drafting this up and figuring out all the details. It's really, really important that architects are occupying their spaces frequently. This is something that's never been possible before, and suddenly, throughout the process, you can actually walk into the space and see what you've been doing and find all of your mistakes and prevent having to redo all of that work. This is where architects start saving a lot of money, starting to, when they're using these tools and preventing rework and doing the job right the first time. So we have design tools. Now we're using this early on as a verification tool. Obviously, VR also as a presentation tool. There's a lot of ways that you can have meetings in VR and you can see this and show your client, this is what we're making you, and then they can understand it right up front. So these are tools that exist already. They're very simple to use. Anybody can do it without needing to know how to program or anything like that. The things get really interesting when you start applying custom applications. And that's, so we do some of this for people and we help firms get set up. But the current state of the industry, there's a lot of opportunity in these very project-focused, fine-grained, I need a design tool that does exactly this. Skip that one. So I want to give some examples. Just some examples from our own work, some from others, that demonstrate the kind of power that people are already applying to their design process. This is part of a suite of tools that we have for medical design. When designing hospitals, most of these hospitals follow a lean design process. So they do full-scale cardboard mock-ups a lot of the time in the past, which are intensely expensive. And when you want to make a design change, you have to say, all right, we're going to move all the cardboard around, come back in a week, while we rent out this warehouse throughout the entire time. So we have these ergonomic studies that we can do where the doctors and the nurses can get in there and start making the changes right there on the spot. Or another example is using these same tools for simulation, where we look at the efficiency of user flow through a space, and then we can look at different design options and instantly know hard data about what is the best and most efficient way to lay out the space. And it's really exciting to get to apply this for firms. We also really encourage designers to begin to understand how to make this stuff themselves. This, I actually made when I was still an architect. It was just for my one project where I needed to lay out a whole campus of, I guess not a campus, development. And I knew how many units I had to fit on there, and I needed to test out different designs. And I got really frustrated designing what I thought would be good, and then jumping in and discovering that it actually felt really bad. But it took so long for those iterations, so I threw this together, where I can be a giant, move buildings around, and then jump in and be human size. And it's so much fun. Also way more efficient. Augmented reality. That's an exciting thing that we started to get into. We expected it to be really just for the construction industry, but we found a lot more uses in architecture and design than we expected. So in this case, whether it is site plans and you need to be able to show a client or physical scale models, we can augment those with diagrams, with details, with animations. If you look on the left there, we're pulling in metadata along with the elements so that you can actually look at and know what this stuff is right there on the spot. Oh yeah, 360 renders that you can open up on the fly. For tabletop, also another example, just using this in one-to-one. This was a project we did for Pollinator, which was they call it design lab, a human-focused interior design laboratory where they wanted to be able to test out different kinds of layouts in the space with humans in mind, and focus more on how people actually use the space and exist in the space. So we set this up for them using the same, it's the same basic technology that is in the tabletop version. So that stuff that's already happening. We went to Helsinki recently for the World Summit on the Digital Built Environment and got to have an impressive survey of what people are doing right now to push the industry forward. And to understand a little bit about where the industry is going. For those who are not in the architecture world, BIM is something that's important to understand. Building information model. In the past, we would draw lines, then we would begin to extract those lines into three-dimensional forms. With building information modeling, it's actually a database of elements more than it is a 3D model. It realizes itself into a 3D model. But a wall isn't a true rectangle, it is a wall with information about that. It's a 2-hour firewall, where does it start, where does it stop? So the industry is moving into BIM, and there's been a lot of adoption, but so far, it's not being, the value of the BIM is not being extracted the way it can be. And so there's a lot of push to be able to work with the BIM more instead of just modeling it and making drawings. In Helsinki, there's a push to have BIM-based permitting. So instead of building a model like this, turning it into a drawing and then getting that drawing permitted, if they get their way, you can save hundreds of hours of drawing and just get the permit right from the information-rich model, which lets people then use more of their time and money actually making that stuff. This was a company we met in Helsinki that has made a tool to design utility rooms in VR because they're extremely complicated 3D spaces that have to all interact, and drawings are a very difficult way to do it. So they have all the different kinds of elements in there, and they can drag and move and design the entire system and then export that to BIM and have it interpreted and ready to go. Really cool team. I want to see that kind of thing happening with more uses, with more trades. Helsinki is one of the cities that is pushing to have open information. So here we actually brought our Magic Leap there with us, and we pulled in the publicly available city model. They've got a photogrammetry version and a BIM version of their city that anyone can access. So we pulled it into the Magic Leap and tried really hard to get it aligned. There needs some work on aligning AR with the real world. That work is being done. You actually, a month or two ago, UAR was here. They're working on the AR cloud. That's a really exciting project, and we're excited to see where that goes. But having this information that people can work with and access without having to pull it from drawings and try to interpret it is really, really exciting. Now, this is the part where I turn profit a little bit, and we can all look back and laugh at what I'm saying, but there are some things that are fairly predictable and inevitable. We don't know how exactly these things will happen, but The AEC industry has been going a long time without increasing its productivity. If you look at value created per human hour worked. And designs have become more complicated as technology increases and design standards increase with fire safety, seismic safety. And so it's been kind of steady. But it seems like that's about to change a lot as some of these automation tools happen. So the big change I see is as XR starts to be married with machine learning. And the two places where this really matters is intuitive design environments and spatially aware construction automation. I actually wrote them in this case because those are very clear things. And the cool part is we're here at this VR meetup, and those are both very XR-related issues that are going to really revolutionize the industry. So intuitive design environments, like we were looking at with that, the mechanical engineering, that can be pushed much further as we are able to do the kind of gestural human-focused design that humans are good at, and let the machine learning take care of a lot of the interpretation of that ends up being most of an architect's job right now, where we are just going back and forth and trying to nail down those details that are extremely rote, I guess. The kind of thing that algorithms are better at than humans, but let humans do the parts that humans are good at. The second part of that is spatially aware construction automation, meaning that to really have these buildings take advantage of the same kinds of processes that manufacturing has taken advantage of, where things become really efficient, you need the computers, you need the machines to understand the space in which they're working. And that's what's happening with XR. I mean, AR is a big part of this. As a little example of this, to try to express it, even though it's much bigger, this is me with the Magic Leap out at Howell Park scanning these historical trees. The giant branch broke off there, and I was like, oh, these are going to die someday, and here's now a record of the shape. So I just went out there and was scanning that. Then, as an experiment recently, I went into Unity and brought a BIM model into Unity and then created a virtual scanner. So these things can go together and you can start to have machines understanding the spaces that they're in and understanding what is in those spaces so that they can work directly with that. Then you start to get this. That's definitely not our work. This is Boston Dynamics. But when you look at this, here's a robot navigating a space. It is understanding a space exactly the way that the Magic Leap is understanding the space. And then it is creating on the fly a nav mesh, which is something that is standard in every game development software suite. This is just AR with robotics attached to it. And all the work that this community is doing here is going to really change where the industry is going. We don't know how, we don't know who exactly, but I'm really excited to see it. I think that's it for me. Is there any questions?
Unfortunately tonight,